Hi everyone, we're going to find the critical numbers for f and find the open interval where f is increasing or decreasing, and then we're going to apply the first derivative test. So the first thing we'll do is apply the first derivative test. This is our function. I rewrote it here, put the denominator under each piece, so that's going to be 1 over x plus 3 over x squared. Just makes it easier to take the derivative. So I take the derivative of x. You do this one. This equals x to negative 1. So it's going to be negative x to the negative 2, which is negative 1 over x squared. And then this piece here is kind of the same thing. This is going to be 3 times x to the negative 2. So that's going to be, we have a plus here. So it's going to be negative 6x to the negative 3. So what you're going to end up getting is negative 1 over x squared minus 6 over x cubed. I can rewrite this. I'm going to pull out the negative and have my common denominator as x cubed. That means I'm going to have to multiply this 1 by an x. So this is going to be x plus 6. Alright, so that just simplifies it a little bit. And now to find the critical numbers, we set this to 0. And that would mean my x is negative 6. So x is negative 6. And we also have a discontinuity. That's critical number. We have a discontinuity x equals 0 because you can't divide by 0, so that's going to generate a vertical asymptote. And we want to check this out and see what's happening on the left side of the asymptote of x equals 0 and on the right side. So when I do my test intervals, I have my two numbers are, my critical number is negative 6 and my discontinuity is at 0. So I'm going to go from negative infinity to negative 6, and then I'm going to go from negative 6 to 0, and then from 0 to infinity, and see what's going on. And we look at our derivative, and our derivative again was negative x plus 6 over x cubed. So we're going to look at the sign of our derivative. So I'm going to plug in, say, negative 7 for this one. If you plug in a negative here, you're going to get a, you're going to get a negative times negative, that's going to be a positive. However, when you plug in a negative into the denominator, you're going to get a negative. So this is a negative. Alright? So this is going to be, our derivative is negative. Now this one, the same thing's going to happen. Any negative numbers you plug in here, I don't know, let's try, we're going to have to try negative 5. So if you plug in a negative 5, this is going to be a negative. And then if you plug in a negative 5 here, you also get a negative. So when you divide two negatives, you get a positive. So my derivative is going to be positive. And then for this one, if you plug in a bigger number than 1, bigger than 0, so let's plug in 1. If you plug in 1, you're going to get, say, negative 7 over a positive number. So this is going to be back to negative. And basically we have, this is decreasing, increasing, decreasing. So we have decreasing, increasing, then decreasing. So what I want to do is check from negative infinity to negative 6, it was decreasing, and then it goes up. So I want to check negative 6, and then after we come back up, we go back down. So I'm going to also check my 0. So basically I'm going to check both of these into and these into my original equation. So our original equation was f of x equals x plus 3 over x squared. So when I plug in a negative 6, I'm going to get negative 6 plus 3, and that's going to equal, negative 6 plus 3 is negative 3 over 36, which equals negative 1/12. Now, so when we have negative 6, we're at negative 1/12. That means that's a relative minimum. Now the 0 we can't plug in because that generated the vertical asymptote. So basically we have an asymptote going on in here. So something's going on with this, like this. So there's no min and max on that. So we only have one relative extremum. Okay. Thank you. Have a nice day. Bye-bye.